Imagine you flip a coin. While it's spinning on the table, is it heads? Or is it tails? Actually, it's both and neither. In the world of the ultra-small, electrons live in this exact state of indecision every single day. Welcome to the mind-bending reality of quantum superposition. For decades, scientists thought electrons were like tiny marbles. But when we fire them through two slits, they don't just hit two spots. They create an interference pattern, just like ripples in a pond. According to the historic Davisson Germer experiment, this means one single electron travels through both slits at the same time.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Wave of probability. Erwin Schrödinger's wave equation tells us that until we look at it, an electron doesn't have a specific address. It exists in a cloud of possibilities. It's essentially everywhere and nowhere at once. This cloud-like nature leads to something even stranger: quantum tunneling. Since the electron is just a probability wave, there is a small chance it can exist on the other side of a solid barrier. It literally goes through walls. Without this, our sun wouldn't shine. Protons rely on tunneling to fuse together and create light. Think of superposition like a ceiling fan. When it's off, you see three blades. When it's on high speed, the blades are everywhere in that circle. Here's the kicker. The moment we try to spy on the electron to see which slit it actually went through, the superposition collapses. The wave turns back into a particle. As Werner Heisenberg pointed out, the act of observation changes the outcome. Nature, it seems, is shy. This paradox led Schrödinger to propose his famous cat thought experiment. If a cat's survival depends on a random quantum event inside a closed box, then until you open the box, the cat is theoretically both alive and dead at the same time. A macroscopic superposition. And if that's not weird enough, meet quantum entanglement. Einstein called it spooky action at a distance. Two particles can become linked so that measuring one instantly determines the state of the other, even if they are on opposite sides of the universe. Why does all this matter? Because you're using quantum physics right now. The transistors in your phone rely on these ghostly electron properties to function. And in the near future, quantum computers will use qubits, which exist in superposition, to solve problems in seconds that would take today's supercomputers millions of years. The universe isn't just stranger than we imagine, it's stranger than we can imagine. If you could be in two places at once, where would you go? One version of you should definitely stay here and leave a comment below. Don't forget to like and subscribe to keep exploring the weird side of science.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.